Yep. Now we're live.
All right. Great. This is my first live, so I'm super excited. Hello, everyone. Thank you for joining us. I'm Shantana, and we've got a great host of folks here joining us. We've got Ryan, co-founder at Tabular. We've got Brian, head of DevRel at Tabular, who's showing off his lights. By the way, I'm working from the boat this week, so this is a real background in the back. And then we've got Roy Hassan from Upsolver, and Jason Hall from Upsolver as well. And we're waiting. At some point, we're hoping that Ethan Aaron's going to pop in. He's, of course, from Portable. But yeah, you guys want to...
Ethan said he's backstage. I just saw the private chat.
Oh, really? Oh, okay. Sorry, it's down.
There we go.
There he is. Hey, Ethan.
I've been back there for 3 hours. Start without me.
My fault.
Did you enjoy the M&Ms? We split them up by color just for you.
It was amazing.
Awesome.
All right, we've got Joe saying hi, Stephen and Val. Hi, everyone. Again, thanks for being here. So, do we want to do a couple words about ourselves? Let's do it. Like, what do you do? Why do you care about CDC? Maybe in very short words. Why don't we kick off with Ethan?
Totally. So I'm Ethan Aaron. I'm the CEO and co-founder of Portable. We're an ELT tool. So we extract data from systems, put it in data warehouses. In most scenarios, we sit alongside of someone like Upsolver in the CDC world. So it's one of those things where it comes up a lot. Not like in most scenarios when we're pulling data, it's not in change data capture capacity, but some APIs have the capabilities, and a lot of our customers have scale issues and consideration. So it comes up all the time. So excited for the conversation today.
Nice.
All right. I'm going to let Ryan go next.
Thanks. So I'm Ryan Blue, co-founder and CEO at Tabular. And I'm also one of the co-creators of Apache Iceberg, which is a pretty large table format that has been gaining adoption, especially in like the data warehousing space lately. I am interested in CDC because the Iceberg journey has really been one to build better guarantees and infrastructure so that we don't have as many mistakes. CDC is a really big topic right now. And when we work with people that are trying to either build their own pipelines or understand how to use some of these open source tools, there are just a lot of problems. I wrote an entire blog post on these problems called CDC Data Gremlins, where the idea is you don't know what kind of correctness bugs are lurking in your data. And CDC is notorious for like being a hard thing to get right.
Brian?
I'll pass it back to Bits.
Yeah. So, hey everyone, Bits or Brian, and I am head of DevRel at Tabular, working with Ryan. So CDC has been an interesting thing to me. Actually, Ryan and I were talking to some folks in the financial industry. I'm not going to say their names yet, but yeah. So they basically came up to us when I was on the Trino side of the house, kind of getting into their specific use cases, and really just came down to this interesting thing of like, hey, similar problem of like traditional analytics. We have transactional data over here. We have the analytics data over here, and we want to effectively like not directly query prod because that would be bad. And so, but we want almost like a mirror image of prod that we can effectively, run queries on and do this whole analytics thing. But keeping them in sync is never easy. It's always very slow with ETL and all this kind of stuff. So what's kind of new in the space these days is this focus on, real time, trying to, instead of just focus on, bringing over the state and updating the state various changes at a time, why not just save the changes? And that way we can materialize things at different times. So CDC kind of enables us to kind of sit in this really interesting middle ground where we're still bringing the changes over to analytics, but where we get a lot more flexibility from that. And we'll obviously dive into that later. So that's my kind of interest.
Jason?
Cool. Yeah, Jason Hall. I'm a solutions architect with Upsolver. My primary role is in working with customers trying to implement various types of data ingestion using the Upsolver platform. CDC being obviously a type of data that customers are trying to work with. CDC is an interesting topic. We're obviously going to dive into that today. It's something that's very simple in theory and very simple at low scale. And I think a lot of the content that you can find out there is that low scale variety, one table, moderate, small amount of changes. Look at how easy this is. Where it gets really complicated is when you start to scale up, and scaling up is in a few different factors that I think we'll talk about today. But so hopefully we can share some best practices or worst practices or lessons learned from the field and have a good discussion about it.
Awesome, and I guess I'll go last. So my name is Roy Hassan. I'm the VP of Product over at Upsolver. Previously worked with AWS on a lot of the analytics services. So spent a ton of time with companies all across the board doing data analytics, data movement in many different ways. And CDC has always been the big one, the one that, once you're moving towards production and you really want to bring those tables that you depend on into your analytics stack, you got to use CDC. And then, like Jason said, doing it, small tables, low volume is fairly simple, fairly straightforward. There's not a lot of challenges. Once you start going up there, you're starting to have a lot of tables. Like I'm talking about thousands, tens of thousands of tables, billion of rows on these tables. Now it starts to get more difficult. Right. And we, working at AWS and also at Upsolver, like I remember some of the challenges that we ran into and how we dealt with those challenges. And I see a lot of companies doing CDC and talking about CDC, but sort of the line in the sand where you go from low volume data and then all of a sudden you start to have a lot of data is kind of getting blurred in the conversation, but it's real. Right, as you move and you get bigger customers who have bigger amounts of data, like you very quickly hit the wall with the current implementations, the current best practices that you see online. And I felt, it was really good for us to kind of bring the brains together and have that conversation. So looking forward to hearing what, Ryan and Ethan and Brian or Bits, however you want to call you, and kind of everybody brings to the table. So yeah, looking forward to this conversation.
So I'll actually go last because I didn't get to talk about why I care about CDC. So as a data scientist or data practitioner, my team and I have done CDC well, and we've also done it poorly. And that's what I really want to talk about is like, what are some bad CDC practices? What are some anti-patterns and why we tend to fall into them? Sometimes I think it is to do with like, it's kind of thought of as something that's hard, like, doing CDC. People don't think of it right away when you're building out your V1 of your software that you want to build out into a product. You're not necessarily thinking right then about, how do I do analytics on this data set? So it's always like an afterthought. I've found is how am I going to actually replicate this data? So yeah, those are the things that I want to touch on also. So let's start with like definitions. Ryan, as you mentioned, your blog post, right? So like, what's the very terse definition of CDC, and which parts do you want to dig into?
Yeah, so I think CDC is a much broader topic, but everyone here, it sounds like, is using it in the same way. So it literally stands for change data capture, which is where you take essentially the write-ahead log from a transactional database and you use that to keep something else in sync, right? So you can have CDC use cases that are like, I want to read the changes off of an iceberg table or something like that. But the hard thing that we're all talking about is really the sort of narrower use case of how do I take a transactional table that I don't want to crush from the analytic world by running, 400 Spark processes that all hit it at the same time. How do I take that data and mirror it into an analytic table so that I can run as many of those processes as I want? So it's really this case of using this change log or change data to keep an analytic table up to date. At least that's how I think about it. I don't know if anyone disagrees with that definition. All right.
Yeah, I think that's, for me at least, I think that's the most common use case of the terminology. Given that we, in our world, pull from APIs, I see similarities with something like a change endpoint at Shopify or Salesforce or one of these APIs where they do throw off changes and you're capturing them and then you are trying to effectively rematerialize them inside of a data warehouse. So like that's the other scenario where I see it. However, 99% of the time, and where most people feel pain today, is transactional data being able to recreate it inside of your data warehouse or analytics environment, whatever that is. Data lake.
Yeah, there is this use case around like, hey, when my when my state gets updated, then I throw out an event or a record that is like the complete up-to-date state of that record. And then, send that through a logging pipeline and use that to like upsert into an analytic table. So yeah, I agree with you there. I think though that is one of the easier cases, because now, I mean, there are some like scale challenges and things around that. But in terms of like the data consistency, the gremlins that can pop up, if your use case is purely upsert, then like that's a good place to be. Where I think we run into a lot of issues is when there are those lurking consistency bugs between rows in your data.
Yeah. Yeah, I think typically when we talk about CDC, we sort of wrap the full end-to-end of the problem into that term, right? Where traditional sort of the term change data capture, like you said, Ryan, right? That's really refers to the mechanism in the source database, right? The mechanism there to be able to replicate data based on the changes that are happening. But then when we have this conversation in the context of analytics, we typically also talk about, well, once the data gets into my target, right, how do I actually merge those results into the target table? How do I do that, right? Which kind of goes beyond what CDC is. It's kind of like taking the output of CDC and using it. But many times when I hear people talk about it, they talk about it in that full end-to-end context. So I think it's important to kind of break it up and say, there's a CDC at the source, right? That's the implementation of the change and capturing the change. And then there is the, what do I do with it, right? There's different ways that I can handle it. I can merge it. I can append it. I can do different things with it. And I think that's the piece that tends to kind of get lost in a lot of conversations. And then once you start implementing that, you realize, hey, there's different ways to do it. Like we could talk about Iceberg and Hoodie and Delta, how they do it, or how Snowflake does it, right? There's different ways. And I think that's where people start to get some of the pain. And I've seen that with, costs increasing specifically around Snowflake, where people are like, yeah, okay, I can do CDC, new changes come in. When I get the changes, update into Snowflake, but now I'm constantly making updates, right? And batching those updates may be a little more difficult because it's not commonly available in CDC tools. So that's kind of the way I see it. But I think generally speaking, it's very similar. The other aspect to kind of Ethan's point is that CDC is traditionally on transactional databases, but what do you do when you have NoSQL databases like Mongo or DynamoDB? What do you do when you have APIs? Now there's vector databases and stuff like that. Do we need to get the data out? How do we get the data out? What does that flow look like? Do we apply the same best practices that we apply to transactional CDC to these type of change, change capture type of databases? Right? We can kind of have that conversation.
It's probably worth mentioning too. I mean, just in terms of scope, I think it was Ryan who mentioned that most of us, when referring to CDC, we're talking about an analytics type use case of getting data from some source into a data warehouse. There is a whole other side of the CDC spectrum, though, where use cases might involve keeping two databases in sync for HA and DR, or keeping a source and target in sync as you migrate from on-prem to cloud. I've seen CDC used for like auditing. Need to keep an audit trail of production database changes in an offline repository, so an auditor can come in and say, show me all the times this primary key column was updated and by who. So, the CDC, I think, I don't want to say for better or worse, but it's a technique. I was going to say technology, but it's not really technology. It's a technique for, you know, getting changes from something to somewhere to be used for some purpose. And there's a lot of different permutations of that. I think we're going to kind of laser in on analytics today, but there is a broader CDC world that might not have much to do with analytics.
I think that's a very important point, though. Like, especially so in the series I wrote on CDC, we start off with like the raw log of changes as like the simplest use case that you can do. And I think that that's important to note for one of the reasons why, you know, you just mentioned, like, what if you need an audit trail? What if you want to be able to time travel to any point in time in that upstream database? There are a lot of use cases here that, you know, you sort of want to make sure you're covering your bases and understand what you're going to use the data for before you choose some method of landing that data or producing a mirror table, because they're not all equal. And, you know, you probably don't realize the implications when you've, you know, chosen some technology first. So yeah, what are you guys seeing in the marketplace or in you know, your experience with like those requirements and what people actually need? Is this a case where, you know, there are 3 or 4 patterns, or is it like, hey, everyone sort of eventually wants this audit trail? Or yeah, what are you guys seeing?
I mean, yeah, I can give you some of the perspective of what we're seeing. You know, I think it's generally a mix. There are many use cases where the customer, the user, really wants a true replica. To say like, I want to replicate the data from my source to this analytics system that I can then run queries against. At that point, there's no need for like an audit trail. There's no need for anything else. It's just, I just want a copy. I want a direct copy of that table from some transactional database into Snowflake or Redshift or Iceberg, right? There's another one where the other popular one, and Jason, jump in here as well, is I want to be able to kind of create a replica in my lake. So I want to have a pen-only sort of log, like replicating the actual changes that are happening, not merging the changes, but here are all the inserts, update, and deletes. I want to have those. Typically, I see that in the lake just because storage. And then from there, they build transformations and models that merge and kind of converge the results in different ways, however they want to do it, into the warehouse where they can do analytics. So that's kind of the 2 primary use cases I've seen. Jason, I don't know if you want to comment on it.
Yeah, I mean, it's interesting hearing where I go through it because where I typically speak with customers, the starting point is just a fundamental, I've got this analytics project and I need to get some data from a database. How do I do it, right? And we might not even start the conversation with CDC. It's just, you know, I've got data, I've got this report, it's going to run off of Snowflake or Redshift or whatever, but I've got this data over here in Postgres or Microsoft SQL Server. How do I get that data in? And so, you know, my job is to start talking customers through options and going over pros and cons and trying to balance requirement versus cost and complexity. And, you know, eventually CDC becomes an option. And to Roy's point, a lot of times the use case isn't well defined enough to be able to say, you know, it starts with, I've got this Postgres table. I need to be able to have it in a data warehouse or data lake. But then you start asking questions. Do you need time travel or replay? Do you need to transform data prior to loading? Do you need data to be, you know, do you need additional columns that you can perform transformations on as you join it with other data sources? And, you know, each of those, do you need this, is going to add some level of complexity and cost and scale that you know, there are answers for, but, you know, does the customer really need that? Or is it nice to have? Is that a must to have? So it's an interesting problem. It's kind of funny. A lot of these use cases get really simplified, or we try to simplify them into table over here, put the table over there. But then you start talking about the mechanism for making that happen, and you get into all these edge cases and kind of difficult scenarios that we're trying to find a way to accommodate.
So what are the basic set of features that you try to include in any CDC project? Ethan, did you want to take that one?
I might not. Let me jump off what Jason said first, and then go into that. I actually tend to talk to people slightly before they're probably even talking to someone like Upsolver. I talk to someone, and maybe it's a one-person data team, and they're trying to figure out, to Jason's point, I just need to build a dashboard on top of my Postgres data. And where I come in, like we're a small data team. Like I am our data team at Portable, as well as the CEO. So depending on where you are in your life cycle, querying production, probably not a good idea. Querying a read replica could be a very good way to start. From there, it's like, okay, maybe you can use native capabilities in something like BigQuery or Snowflake. If you want something in near real time, it becomes absolute chaos to actually query over time. Then it's like, okay, speed, you could like batch load stuff into your data warehouse, but like now it's immediately out of date. And that's when things, it's like to get started, that's what people typically do to solve that problem, Jason said, like really, really early on. And they very rapidly realize that once they have a use case, like typically all the stuff I just said is to find the use case. It's like, why do you actually need the data from Postgres? If you can't answer that question, I typically say don't invest in the infrastructure yet. But once you know that you need the data and you need it quickly and you need it to be up to date, that's when I typically see people move to change data capture. It's because they actually know the analytics they want to run on this data. And sure, you could use something like effectively copying entire tables over, but it's going to become out of date. It's going to become too costly. It's going to be really annoying to do. So people then move to change data capture. And that also unlocks things like replays and just scalability and speed.
So does it unlock replays?
or it gives you the ability to see the data that you're not going to see otherwise. So that, typically it depends on kind of where you are in that life cycle. But a lot of the times when I'm talking to people, because on our side, like we're not actually doing change data capture, we're sitting alongside of it with data teams. People are trying to solve a business problem first and foremost. And I think forgetting about that is a mistake. And in most scenarios, it's like, what are you trying to do? And if you're trying to build a product, if you're trying to get better insights into the history of all your data, querying a read replica is not the scalable answer as you go deeper into this stuff.
Well, and to Ethan's point, this might be obvious, but I think it's important to like take a step up and say, you know, a lot of users come to me and, you know, again, I kind of overly simplified the use case of I've got a table over here, I need to get it over here. But without understanding like what you're doing with the data, once it gets over here, it's impossible to kind of recommend how you're going to get that data in the most simple and cost effective way. You know, to your point, Ethan, like there are plenty of use cases where customers start looking into very complex and sophisticated CDC mechanisms for transporting in data. And all they need is a daily snapshot of a small table that they can join some event stream to. You know, it's an enrichment, you know, table. And so it's really easy to over-engineer something in the CDC world that doesn't need the level of over-engineering that you've put into it. And once you over-engineer something in CDC, the potential for, you know, challenges due to that complexity is just through the roof.
Yeah, I mean, I agree that over-engineering is definitely a problem, and it's something that us engineers love to do. But I mean, the other point I will bring up is that the tools that we have today, is a real difference between connecting to a CDC stream or doing daily snapshots. From an end user perspective, isn't it just a flag or like a configuration in their tool to say, read this real time or read this once an hour and move it over? Like, is it real like an over engineering problem with the current tool sets that we have? If I was to go build this in Spark myself, yeah, it's a bigger question. But you know, I think most of the tools that we have today, even if you look at Upsolver or Portable or Estuary or some of these other tools, it's a simple checkbox that says how frequently I want to move the data. So the user doesn't really have to think much, right?
Totally. I'm curious, Ryan, when do you think people shouldn't use change data capture? And then at what point do you think that toggle should switch from off to on? Or do you think it's a from day one, you're standing up a data stack, even if you're going to be a one-person team for 2 years, like use change data capture. Kind of, I'm curious how you think about when yes and when no on change data capture.
So for me, it is usually an assumption of the people that we work with, because we're working at those scales that, they know that they don't want to, have a process hit their production database. And they're probably already getting to the point where a read replica is not scaling and not efficient. So, I mean, but if I'm thinking about this in the abstract, it is try a read replica first, right? Like just go query the read replica. And if that satisfies your needs, then don't worry about it, because that's a couple clicks, right? Then I think that we're getting to the point with services like DMS that can automatically produce the data. I mean, it's a pain to do this, definitely, but we should be getting to the point where that Roy is talking about, where it's like, okay, you produce data, right? Some system ingests that data and gives you a mirror table on some periodic basis, and you choose what that basis is. The over-engineering comes in when people don't think about their requirements, to your point, right? If they're like, ooh, I want this up to date every 2 seconds. Well, I mean, so my most recent blog post on this was like, look, updating the mirror table is work, right? As often as you update that mirror table, you're either creating deltas or you're creating, you're rewriting data files. Like if you do it once every 5 minutes, that's, once every 5 minutes worth of work. If you do it once every 30 seconds, that's 10 times the amount of work. So like, think about your requirements before you just jump to, I want to do 10 times the amount of work. If it's, I only need this daily, or I query this so seldomly that I don't even need a mirror table, that's great.
What are the other like silent ways in which not having CDC in place cost time and money for people? Like I was talking to someone, it's a financial services firm, where they started off building some reporting once a day, and it was great. And then it ended up in their product, and then it was powering the product, and it was powering actual workflows for the company. And then they were like, wow, this is great, but like, it's not built in a way to like go much faster. Let's just run it twice as often. And then they're like, let's just run it again twice as often. And then their bill just kept going up and up and up to get to, because it became this product. What are the other scenarios? Like frequency seems like one. It's like you need data faster. What are the other things that someone, like as a non-technical data person, as someone who doesn't understand the intricacies of why, like what are the things that someone should be looking at in their data pipelines and be like, like Roy told me this is a bad idea. Like Ryan told me I should call him in this scenario. Like what are the scenarios and the symptoms people might be feeling when they should pick up the phone and be like, I think I have a problem here.
Yeah. Roy, do you have a?
Yeah, I have a perspective. I want to hear yours. I want to hear Jason as well. He's dealing with this every day too.
So I normally come in when these pipelines are badly architected on top of open source Iceberg. So that's why I'm, my stuff is focused on, squashing some of those bugs. Probably the scenario we see most often is someone says, I want this every 30 seconds, or I want this every 15 seconds or something like that. And they're only going to read it once an hour. And they're just doing way more work. And so, yes, we get to this cost angle. Or they say, aha, I know that I can use deltas, and I can use like a merge on read strategy to do this. And so they start accumulating deltas at that rate, and they accumulate thousands and thousands of deltas in their tables, and they don't realize that those things also require maintenance, right? We also see people that have, this is when they're coming from other formats. We see people that just start having inconsistencies across tables. That's a one. And then the simplest is just they've chosen another format and it doesn't support schema evolution. So the first time they rename a column in the Postgres database, they're hosed, because they're like, oh no, I renamed a column and now my mirror table is completely out of whack. Yeah, and then there's some other subtle things, but yeah. Sorry.
Yeah, I would say what Ryan just mentioned there is, if I was to blanket customer challenges or try to compartmentalize them into buckets, the schema evolution scenario is one that comes up often. It's multifaceted. It's you think of a relational database as being highly structured, right? The schema shouldn't really evolve by nature. You build a table schema in Postgres and your data fits that model. But it's these ad hoc changes that are made, changing of a data type. It's a once a year thing maybe, but when it happens, what are all the downstream things, in this case, CDC pipeline, that has the chance to just completely break? And also there's nuance to CDC we're talking about it in generalities here, but each database platform that has a CDC option treats CDC differently. SQL Server, Postgres, MySQL, Mongo, they all, you can turn on some form of CDC, but like one I came up across recently with Postgres is customer added, I think the exact scenario was they added a new column to Postgres with a default value.
Yeah.
And they expected that default value to populate into their data warehouse. And they had built these downstream reports that needed that default value, but Postgres doesn't replicate that for existing records, right? It replicates the default value for newly inserted records, but not for old. So like these edge cases that involve a change in data because the schema has now evolved, you think, in theory, I've got CDC turned on. I shouldn't have to worry about that, but you do. And there's so many of those cases that have, and a lot of these systems, once your source and targets get out of sync, you don't have a lot of options other than starting over. And that can be pretty painful depending on the scale and complexity of what you're trying to replicate.
Yeah. I would also add,
So, I think it's important to think about the cultural aspect as well of CDC, like this sort of thing that Jason just described. I think one of the reasons is usually it's like there's a divide, right? On one side of CDC is the product development team that's thinking about that Postgres database data structure and what columns need to be in there and what makes sense. And then on the other side is the data consumers, and they're thinking in terms of, oh, I want the reporting to have this default value of this field. That is a very data way of that's a very reporting centric way of thinking. Like you're thinking about what you want the report to look like or the dashboard to look like, and you're saying, okay, I'm gonna just hard code that in at this. I mean, it's not hard coding, but I'm just gonna put that into the source, which is nothing to do with the application itself, right? So.
Yeah, I mean, I want to jump on this one as well, because this comes up pretty often in our world, right? I think one of the things that we sort of noticed fairly quickly is that when we talk about data ingestion, when we talk about using Absolver for CDC, initially we thought we were talking to data engineers, but then we very quickly realized that we're actually talking to software engineers. We're talking to application developers. We're talking to people further up the stack that are interested in saying like, hey, I got a bunch of data. I don't want anybody touching my database. I will get that data into your Snowflake, your Lakehouse, whatever you want to get it into. I will do it for you. But I don't want to have a hard dependency on those downstream analytic systems, because if I want to change my schema because I've added a new feature, I changed a feature, like Jason said, right? Like a data type shouldn't change, should change once a year, but in the world that we live in now, like it doesn't, right? Application team can come back and say, we just launched a feature and we want to have a new data model. Well, hey, that feature just completely is useless. Nobody's using it. We're going to deprecate it. Now we want to remove that piece of the schema. So what we're hearing in our conversation is that these application developers, they don't want to be dependent on a downstream system. Like I don't want to say like, hey, analytics team, I need to deprecate a column. Oh no, you can't because I'm depending on it. Like I want to move fast. I want to be able to do what I want to do. And I think that's a bit of a cultural thing, right? Like different teams need to work together without taking dependencies on each other as much. But also we need to be able to provide the tooling and the flexibility for them to actually act independently and let the systems in the middle sort of figure out the complexities and sort of how to map those things together. And it's easier said than done, but it's something that, instead of asking users to say, go create a contract and map the types together, we should be able to do it for them.
I had a quick point. Oh, do you want to?
No, I just wanted to say I agree with that. I think this is an infrastructure problem, not a user problem. But that's been my soapbox for a while, is like all of these things we just put on data engineers and assume there'd be a data engineer there. So we need to stop doing that and just fix problems.
Yeah. And getting back to actually one of the questions that you had, Ethan, around like, when should you start thinking about CDC? That's outside of just like, separating these things at scale. And so I think another use case that when we think about how to make things easier for the end user is really coming down to how complex are your like auditing reports and things like this. Like how much granularity do you need to actually see like, hey, at this state and time, let's say, this various transaction, this kind of thing, do I need to actually be able to see, just the state it is today, downstream, basically getting that effective mirror? Or do I care about historically the context and how things have changed within that table or data, or across multiple tables? What level of complexity is my actual queries when it comes down to like data, like consuming the data and actually making sense of how things changed over time? So that's another aspect we haven't quite hit on yet. And when you think about how we're actually going to store that data, I know that, Roy, you were saying this is getting away from CDC proper, but I still think that, again, thinking about your downstream use cases that you're caring about ultimately drive if you need CDC or not. And so this is one of those really common ones now where, well, people need audit and they need to understand how things changed over time, who changed them, and this kind of thing. You really have to get into a state of, well, I can't just be mirroring state the entire time. Otherwise, I just know what's going on today. I need to actually be, not just storing the change, or not just updating the changes and materializing it immediately. I have to actually store these as, as changes, as logs. And then at that point, I have the flexibility to, for however long I'm maintaining that, it could be, however long you need at that point, just materialize it at any point down the road, especially like, say, something happened a year ago, and you just now discovered some problem that some bug that was introduced at the time, and you have to go back and chase that down. If that's part of what you need to be able to support, like, you should be actually recording the changes, not necessarily the core data. So that's one of those ways that change data capture itself is actually going to be another downstream win for people that are actually using the system. And again, being able to produce these types of complex reports, historical complex reports. So
I want to highlight that as well. Ethan, you mentioned something like, oh, you want to be able to consume those changes after you're done. And that's exactly what, we actually see a lot of people assume that in a batch system, and these are all batch systems once you get to the analytic world, assume that in a batch system, you can consume the changes from a table as though it were a CDC log itself. But because we're batching them up, you lose changes. It's pretty common for me on, whatever website, when I'm changing preferences and settings, I go and change like 3 or 4, and those all get batched up into the same write. And it looks like I went from state A to state D, even though that wasn't what happened. And a lot of these systems lose those changes because of the batch nature. So if you're assuming that you can then consume those, yeah, you can get to the end state, but you can't safely reproduce every single change for, say, Jason's auditing use case. Yeah. Or if you want to, actually have a count of, hey, the number of times someone came in and changed a setting. So we see a lot of misconceptions about the representation here and how it really limits what you can do with it afterwards.
Yeah. Yeah, no, and I think, you know, that's kind of like in my mind, when I talk about CDC, I tend to sort of break it up into pieces as opposed to saying like, oh, it's one big thing, right? Because a lot of times CDC is just about the input, right? How you apply the output is not necessarily a CDC question anymore. It's really about what do you want to do with that data? How do you want to apply those changes? Do you want to incrementally just append them? Do you want to merge them? One of the things that we've done on Absolver to try to simplify that model for users is actually when we do CDC use cases, we actually do break it up into two pieces. We have the input part where we write the data into the lake, and it's basically like replicating all the changes. Like we don't merge anything, we just create a change log in the data lake, right? And then from there, we let users create independent write jobs that pick from that change log and say, for that particular table, I want to merge. For this table, I want to actually append, right? For this table, I want to do SCD type 2, right? So you have a lot of flexibility. This way, you're not tied end to end and say, well, if I'm doing CDC for table X, it must be a merge into the target. Like that may not be my use case, right? You've seen that flexibility is super important because we've seen the costs of Snowflake and other warehouses just completely skyrocket when you're trying to do, you know, semi-real time, you know, let's say down to a minute freshness of replicating CDC into a merge table, right, where you're merging. So we had to sort of implement this. This is why when I talk about CDC, I always try to like separate it. Like what are you exactly trying to do? Reading it is cool. Let's read it as fast as we can. But writing it, let's have a conversation on what your use case and what your needs are.
Yep.
It's funny that I was trying to lead to exactly this with one of my earlier questions, like what are the things that you always put in these CDC pipelines? Because although we've been talking about, you know, different challenges of doing this, when I talk to people who have done it right, and it sounds like you guys are in that camp, everyone has the same approach, which is land the CDC changes in a change log table, then have downstream tables from there with, you know, different freshness settings, different, configurations, right? Do you want, how you want to handle historical data and things like that. That way you have the full changes for auditability, and you can sort of tweak and replay and do all of the things that you need to downstream of that. So that's really funny that like everyone seems to be coalescing around that basic design.
Yeah.
The thing to me that's so interesting about this, oh, yeah.
I was just gonna say, yeah, I mean, we've absolutely fully agree that you know, the design has to be use case driven. We've talked about use cases, but I feel like we haven't quite emphasized the spectrum there is. And I don't, Ethan, if you wanted to respond to Ryan, we don't have to digress on this too much. But you know, there is the analytics use case where you usually have like longer time frames over which you can answer questions, and batching things up makes a little bit more sense because you're more interested in the state than the journey to get to state. So you might actually only care that you went from A to D and not through B and C in some cases. But and then there's the real-time production workloads, right, where you have microservices that need to talk to each other and that depend on each other, and there we're usually communicating via message buses, right? But then in between space, let's say I have an e-commerce website or something like that, and the client updates some details about themselves, and I want to change my recommendations based on that. That doesn't have to be super real time, but it also shouldn't take 36 hours for that change to propagate through, for me to make that association and then update back into prod, right? So that middle portion is often today what I see is it's being done in batch processes. It's like, okay, let me get all of this data from this microservice and then this other data, and then every night I'm gonna coalesce these into my user understanding, right? And then I'm gonna train my ML model, or train my ML model based on that. But could those applications benefit from CDC? I mean, it's a leading question because I think they could. But again, like, what what is that switch over? What is, why aren't we doing more real-time applications with CDC, I guess?
Ethan, do you want to take it, or do you want to? I can take a pass at it.
Go for it.
No, I think from the real time perspective, and sorry, maybe I just queued off of the last sentence there. I think real time CDC is definitely interesting. I think in reality, CDC is for the most part real time, whatever your definition of real time is. It's really being able to capture changes as they're happening, right? Whether you're, a millisecond, behind or a minute behind, I don't think it makes that much of a difference. Unless you're Uber or Airbnb or somebody like that. But for the most part, a minute is good enough. I think the challenge that we see with real time is that, at least what I've seen with people, is typically when you say the word real time, when you say streaming, people kind of take a step back and say like, whoa, hold on a second. That means I got to rebuild my architecture and build the streaming thing, and I need to add Kafka, I need to add Flink, and I need to do all these things. I think people just kind of get heartburn when they hear the word streaming or real time. But in reality, it's not really that hard. Like, you don't really need all those things. Like, of course, if you're doing, 5 million events a second and you're pulling data from your applications and you're acting on it, that's a different world, right? But for the case of bringing fresh data into your warehouse, into your lake, CDC is that real-time use case, right? Like, you don't need Flink for that. You don't need Spark for that.
Right. To be clear, I'm not saying that CDC doesn't have a part to play in that when you want to do things real time. I think I'm actually saying the opposite. Right? Like, you've got these set of applications where people think, okay, real time, so let's get those message buses, message queues going. And then immediately after that, the next thing is, there's going to be a 24-hour lag because my orchestrator runs every 24 hours to do this thing that some cross application, cross service analytics. But I feel like there's so much arbitrage opportunity there to have CDC play a part and like just shorten that life cycle from 24 hours to like 5 minutes or something like that. Makes for better client experiences, in my opinion.
Yeah, I think that's the important context. It's you need to think in terms of like 5 minutes, 15 minutes, something like that, because it's just needless expense if you're going, any further than that. I like to use an analogy of like sports cars. Like, sports cars can go really fast and they can accelerate super fast. But do any of us drive sports cars? No. I mean, okay, maybe. But like, I drive a Prius because it gets excellent gas mileage. And that's, there are other dimensions besides real time and super fast. The, reliability of the pipeline and, the efficiency of the pipeline. Those are things that you're going to realize well after you've built and gotten this thing in production, like moving data every 30 seconds. You'll be like, holy crap, this is expensive. I need to trade in the Hummer.
just don't ask Ricky Bobby, right?
Well, it's an interesting scenario because like real time as a term could mean anything, to your point, Shantana, of sub-millisecond latency up to 30 minutes for some customers might be a perfectly adequate real-time use case. And, CDC as a mechanism can deliver data, can deliver changes pretty quickly. There's some things to consider about, that will determine how quickly. But, for most use cases, I think CDC is going to offer a real-time enough pipeline to what most customers are going to use it for. And if it's not real-time enough, I had a customer the other day asking me about sub-millisecond latency on Postgres transactional data. And I mean, maybe you could, in theory, architect something that could give you that. But then like the what if scenarios of needing to re-snapshot a table, or what if you do a batch update in a 500,000 record, table? Are you realistically going to get that to accomplish from source to target in sub a few seconds? No. So like it's you're architecting. I mean, CDC is really good for the vast majority of real-time use cases, unless your real-time use case is so real-time that honestly we should be talking about a completely different technology stack altogether.
Yeah, I think once you get to that, then you can kind of look at streams, right? Sometimes when you talk about CDC, like people refer to event streams where, I'm writing one event to my database and I'm kind of writing a copy of that event into Kafka, right? Or I'm using some kind of outbox pattern or something like that. In that case, it's a lot more real time, but that's no longer CDC, right? That's no longer the traditional CDC.
So these also, like some of these things that we're talking about now actually also go into some of I think the question was just lobbed up earlier about, common challenges you see in implementing CDC for customers. This general topic is one that I see often, where you get a CDC pipeline set up. You've got some baseline requirements on, 30-minute freshness, let's say, and you build a pipeline and it works perfect for, a while. You have no issues. Source to target is never out of 30 minutes in sync. But then there are oftentimes these events that can cause that to blow up. Having to reload a Postgres table. I've seen some scenarios with MongoDB where if you need to rebalance partitions or rebalance shards, that involves a huge amount of updates to update shard keys. I've seen issues with MySQL. I think it was certain types of reindexing can cause all sorts of changes that you maybe didn't anticipate. And now all of a sudden your CDC pipeline that was never more than 30 minutes out of date is 36 hours out of date. And it's how do we engineer for that is a challenge. So these freshness requirements are important to kind of nail down. Is I guess my conclusion to this is how real time do you actually need it to be? And in most of the scenarios, CDC is a really good fit for that. But then there are also going to be what if scenarios that you need to accommodate for in kind of ensuring that that's actually going to be the case.
It kind of reminds me of, I used to be a product manager at LiveRamp, and then I was the head of data at LiveRamp. And if you actually ask 10 people, what is a real-time use case for this data, and you get 10 answers, 9.5 of them are not actually end-to-end real-time data pipelines. There's some aspect of the process that has to be real-time, but if you actually think about it, it's I want to do real-time marketing. It's cool. You can change it to capture your data, create an audience, and then send it in a batch file to an advertising platform. It's going to take 3 days to get there. It's cool. That's not going to be real time. Or it's oh, you have real time requirements because live on the website, when someone logs in, they have to be able to click a button that shows them information live on the website. It's yeah, but do they care if it's actually up to date to the millisecond? Or if it's 3 hours old, does it matter? Probably not in a lot of respects. So it's there's the general use case of does it actually matter? But I think to Jason's point, data pipelines, as they become more and more batch, we're an API company. Most of the data pipelines we have are entirely batch. It's you move your data every day, every 6 hours, every hour. As that expands, you run into more and more potential problems. Things can become out of sync if you're running an orchestration job every 24 hours that kicked off 1 minute before your last load job. Now your data is 48 hours old. That's the type of stuff where speed for the sake of speed doesn't help, but it removes uncertainty. And I think most data teams are just want as little uncertainty as possible. Kind of reminds me earlier, Jason, of your point around all the different upstream systems have different change data capture mechanisms. And same thing in terms of how you're loading, whether you're merging data or you're appending data, et cetera. And when you think about change data capture, there's the idea of who actually really should be an expert at this? If you are the analyst, do you really need to be an expert at how Postgres exposes change logs and then whether you use a merge or an append operation? Probably not. So when I think about things like change data capture solutions like Upsolver, it's not just how do you technically get data from point A to point B, but it's also just being able to call someone else that actually spends 24 hours a day on this problem to just be hey, Jason, hey, Roy, hey, Shantana, I don't know what to do here. Please just tell me the best approach. Or to Ryan's point of hey, these are the best practices. 99.5% of data teams should not be experts at the best practices in change data capture. it's just not what they should be spending their time on. They should either be software developers building applications, dealing with migrations in their upstream systems, or analytics teams. The only other 0.5% of these are massive enterprises where they've decided they have to build this up in-house. In all the other scenarios, when I think about solutions in the change data capture world, it's not just how do you get data from point A to point B, but it's do you understand the nuances here? Because if not, like, call someone that does. Because yeah, you're either in this world or you're not. Like we've decided not to be in the change data capture world ourselves. We are in the API world. So if you have any API questions, let me know. But they're fundamentally different worlds. Like the level at which we read API docs is the level at which the Upsolver team is understanding change logs, and most people shouldn't be doing either one of those.
I agree with that. I'll also mention, Roy said earlier, like, hey, maybe if you're Airbnb or someone, you're, going to that level of detail. Even at Netflix, we used the simplest approach possible for our CDC. We honestly, we kept changelog tables and we put views on those changelog tables. And if someone complained or if we noticed the cost, we would do something about it. that was it. And it's so easy to know that, hey, 95% of your tables, even at a Netflix, fall into that you don't care category.
Right. You just want it to be fresh. You don't want to go there and the thing hasn't been updated. But does it have to be a minute? Does it have to be a millisecond? Probably not. Right. Because at the end of the day, we're looking at this for analytics. I guess the question is, I feel like a lot of these conversations we're having is with the hat of analytics. The question is, will this change? Now that we're looking at this data kind of being ingested from different systems, getting processed in, whatever your definition of real time is, and then fed into online training or online, prediction models, and not so much for analytics for the purpose of running reports or dashboards or those kind of things. Do we feel like that is now changing? Do we feel that real time actually is more important and is going to become more difficult because the ultimate use case of the data is machine to machine, right? Is an algorithm or is something that has to respond to another human?
I don't think that we're even in a state where that can be possible yet. I mean, so maybe this is just me thinking about a problem that I've thought about a lot, but transactional consistency in CDC tables, knowing that if I insert or upsert a record in table 1 that has a relationship to table 2, that relationship is preserved.
Right.
That I don't see hardly anyone building to that, right? We've been building to that standard because we have financial customers that are like, hey, yeah, we can't just drop transactions because one side of the transaction doesn't exist, right? But the kind of machine to machine real time use cases that you're talking about absolutely require that, right? You can't have this giant question mark in the quality of your data, which is like, oh, hey, if a query ran over here in my transactional system, I expect the same result in my analytics system.
Right.
Well, if you're just randomly inserting records at who knows where in the change log, and you don't have some mechanism for saying, okay, everything is up to date to the same point in that transaction log, you really have no guarantees that your queries are going to be correct. And until we solve that problem, I don't think we're going to approach this idea of actual real-time or near real-time use cases, because we're so far away from being able to do that today.
Yeah, no, it's a very good point, and we've been working with our customers and obviously our engineering team to kind of address that consistency problem. I think in many cases, unless that consistency is a deal breaker, like financial services and things like that. What I've seen a lot of times, and maybe that's not a lot of times, but what I've seen in times is that people sort of click the button of CDC, move the data, and I'm done, right? They kind of wash their hands from it, and I'm just gonna assume consistency is there. For small data changes, small tables, infrequent changes, that may be okay. But I think as you start ramping up in the volume of data and the scale of changes, that becomes a much, much more difficult problem, right? And that's kind of where, I was talking about in the beginning, where the line in the sand is. Like you kind of hit that line, and then you say, like, now I got a problem, right? Now I got to start worrying about this. And that's what we've seen coming in and working with customers who have a lot of data, is that, we have to take out existing systems that were nice and easy and could give you that easy button, but just didn't scale. And now that you have this consistency problem and scale problem, now you got to replace everything. And that's often kind of frustrating. Like you spend all this time and all this effort and built all this stuff. Now we got to tell you, hey, look, these tools aren't going to solve this problem for you. You got to find a different way to solve this problem. You need to build it your own, which I don't know if you want to do that, or you can go build, buy a tool that actually cares about those things and have dealt with it in the past and know how to solve those problems.
I would just settle for people knowing whether a system for CDC, mirroring is eventually consistent or not, because I think a lot of questions and, challenges around like, hey, why did I get this result are stemming from the eventual consistency of certain, patterns or use cases. And, just knowing the approach I'm taking is eventually consistent versus, I have these consistency guarantees is a huge step forward. Because at least then at the outset, and this is like another thing that we keep doing is we give people the tools to sort of cobble together their own infrastructure without actually giving them the knowledge to make good choices. And so they've made like 10 choices by the time they realize what they should have been looking at. Eventual consistency is one of those problems.
Yeah. Eventual consistency has always been a problem in cloud, right? With S3 storage, and now we're definitely seeing it here. I wanted to bring it up earlier when you're kind of asking, you mentioned, when you obviously working with customers who are interested in Iceberg, we work with a lot of customers who've implemented Debezium, right? And Debezium being an open source CDC tool on the surface, seems to be great. It has the right connectors. It seems to be doing the right things. But once you start getting into the weeds of it and you start implementing it and you start, configuring it to Postgres and to SQL Server, and, your volume starts to increase, now it becomes much more difficult to be able to maintain consistent updates and making sure that you catch all the schema changes that are happening, and they don't automatically evolve schema. You got to handle these things on your own. And this is where things starts to get complicated. And that's usually where we catch, users like, hey, I've done this, now I got to do schema evolution. I got to build all these transformations, and it gets really out of hand very fast.
It's interesting, Roy, to your point of like, are we seeing AI as a catalyst for this, or generative AI, or any of this stuff? I actually think the catalyst I've been seeing more recently is just data teams and engineering teams kind of converging, or they split, and now they're converging back in terms of like, who's actually accountable for the metrics inside of a product? Like the actual stuff that's being exposed to a user. Whether if it's transactional, yes, all the guarantees matter a lot. Like if you show someone a bank account balance as of 6 hours ago, like depends on if they're going to try and take money out of that or not. But I'm seeing a lot of data teams now accountable for parts of products. And I think the minute you put something up there, like an embedded dashboard or some metric, speed starts to matter, because people keep asking. Speed and consistency matter a lot. And you blur the line between engineering responsibilities and data responsibilities, because at that point, once it goes in the product, no data team wants to give the responsibilities away. They don't want to be like, oh, it's in the product. Now the engineering team will take over all of my logic, data pipelines, et cetera. And the engineering team does not want to be accountable for whatever the data person wrote in 1,000 SQL statements to get there. So it's one of those things of, I think that's an interesting catalyst right now for both data quality, data observability, speed, and consistency above and beyond most other things taking place in the market. It's just external clients, depending on your data, like causes some real accountability in terms of.
But even to that point, right, do you still have the requirement for near real time, right? If you've got a dashboard that shows like the last day of activity, does it need to update every 30 seconds?
It depends on the use case. So like the use case I was talking about with the company is like, it was fraud detection. And if they encountered fraud, they were shutting out people's credit cards. In that scenario, once a day might not work.
Totally. But in that scenario, aren't you going for a Kafka pipeline, a streaming infrastructure? Like if you're involving your data team in fraud detection and making sure that like a CDC table getting up to date is...
It's interesting because it depends on how you got there. If you got there by let's build a fraud detection product that automatically turns things on and off, 100% you go with an engineering-based solution. What they actually started with was dashboards to show people insights in their transactions. And then it was like, okay, cool. Based on what's actually happening here, this is useful insight for our team to understand what to do next. And then it was, okay, cool. Like we have these dashboards, these metrics, our team's doing these things. What if like, and it's one of those things where it's like, should they have just started over before they toggled on the automatically turn off accounts button? I think that's where there's a lot of, the lines are blurred right now between engineering and data teams of when does something get deployed to production? Like right now it's way too easy. And like you see it with internal reporting as well, like internal reporting that starts being used for investor relations and then public reporting, like same thing. It's like, at what point does that toggle get switched from this is just an analytics dashboard to no, it's not. Like this is like there's serious accountability here. I think those lines in the data world keep blurring. And yes, if you knew you were building financial reporting for regular, like for people, like you'd sit down and architect it from an engineering perspective, just like you would the fraud detection use case. I think right now we're seeing data teams and engineering teams not realize when they cross that line. And the more production systems you can put in place earlier, the safer you might be as you get closer to those use cases.
Yeah, good point there. And you might just have a situation where, you pay down the pain, right? It's not uncommon to say like, okay, well, the proper engineering solution is going to take 3 to 6 months worth of work, or we can just, pay for it. Right. And so you hold your nose, you pay the bill, and you engineer something to replace it in the background.
Yeah, I think that's a big part of it. I think there's another part of it where you hear this often about, just go quickly, get the job done quickly, and think about the problem later. Right. And I think that's one of the issues that we're seeing is that we're kind of like running as fast as we can. And we don't necessarily think about it. We'll deal with it later. It's somebody else's problem. Maybe it's not my problem. Maybe it's, the data team's problem. And then you end up with, kind of finger pointing. And then nobody wants to deal with it. Everybody wants to build it differently. And then you get into this whole other problem that, you probably shouldn't have been there in the beginning.
I don't want to downplay. It's like people should have known when they did all this. Like, yes, you should have. In some of these scenarios, you absolutely should have. The other thing here about all of this is like change data capture, just the one part of like reading the write-ahead logs, is unbelievably complex and complicated. So it's one of those things of if you don't fully understand every single intricacy of how data moves from point A to point B, like not who's at fault, but it's like it's a really complicated problem to get data from point A to point B. And I think you either gloss over it and you're like, yeah, good enough, great, until proven otherwise, which is for some use cases, if it's like internal reporting for KPIs, probably not the end of the world. If it's accounting, it's a problem. Don't do that. But it's like, it's this interesting, like even if you truly prepare, it's still really complicated. All these problems are really complicated. And I think trying to like, especially when most of the data workforce is pretty junior, it's a really tough thing to solve at scale as an industry. It's like, how do you take a lot of junior resources and a lot of really complicated problems and make sure that everything is perfect? It's quite difficult.
I think some of those problems too, they don't maybe sound as complicated on the surface when you spell out the problem statement, because throwing myself under the bus, I spent the first 15 years of my career managing relational databases that some of these challenges from the analytics world just didn't really exist. Like transactional consistency hasn't been a problem with relational databases forever. I mean, that's probably wrong, but things like ordering of events, right? And in the analytics world is a big challenge. When you're talking about real-time event streams and separate event streams that need to be kept in sync, ordering of events is everything, right? And in CDC, it's of course everything, right? You can't, if you get 2 events out of order and it's a CDC pipeline, that breaks everything. You can't delete something that hasn't been inserted, and if you update 2 things in the wrong order, your data state has broken. So sometimes I've explained some things to customers, or even just brought up comments in talking with users about, oh, have you considered this? Customer may be guaranteed by its very nature, but it's not always as simple as it is. So to your point, Ethan, I think that's CDC fundamentally sounds so simple, and some of the challenges don't sound like they should be challenges, but once you start implementing things, especially at production scale, they become really hard problems to solve.
So, okay, I want to bring a slightly different angle here. Like going beyond folks who sort of understand that they need some sort of CDC, right? Like, let's say that we're all talking, or at least from the Absolver side, let's say that we're talking to folks who at least are coming in saying, okay, I need a CDC solution, or as Jason said, I need this data replicated over here for XYZ purpose. What are my options for the solution? There's also like, how do we and maybe they're understanding that it's a difficult problem. It's a technically difficult problem. It's better left to the experts to solve. And there are some standards around how CDC should be done that we've coalesced around. But there are lots of, like, talking to a more broad audience of data, especially data engineering and like engineering focused data engineering and software engineering folks that are not doing CDC, not using CDC. Their use cases, they have things in place that are satisfying their use cases, right? So if it's like analytics based, maybe, or if it's like, let's say it's application health based, right? They're using the Datadogs, the Prometheuses. If it's analytics based, then they have some ETL process that's eventually getting the various service logs and things like that, and doing a representation of the business data. And if it's like super real time, as we said, Kafka, right? So they're just not seeing CDC as a necessary part of what they need to do. Like, what's our approach there? Or is that just fine? Like, if you don't need it, you don't need it. It's a difficult question. Lots to unpack there.
I typically argue, like, you need a catalyst. Like, you need a catalyst to transition from using, like, to Ryan's point, like, if you're going into a massive enterprise and they're just like, we need a solution at enterprise scale, it's like, cool, maybe digital transformation is the catalyst. For smaller companies, if someone's using a read replica to power insights, like, at some point, maybe not, but at some point, probably you're going to need to query the data from that read replica alongside of data from other systems, whether it's other databases or applications. In that scenario, you probably actually want all the data inside of the same data lake or data warehouse or something, so you can actually join these data sets easily. So I typically recommend, like, wait as long as you can for the catalyst. And that catalyst might just be, as a company, we're going through digital transformation. We need to clean up a ton of tech debt that we've accumulated over 30 years. It also might just be, finally, I want to join the data from my database to the data from my applications. I don't think trying to create that catalyst, if it doesn't exist for someone, is the answer. Unless you can point to either saving money or powering new revenue for people. But I think it comes down to what's the catalyst.
And Ethan, on that, you were saying, hold off on the catalyst as long as you can. So, like, what are some strategies that you've recommended in terms of, like, hey, this is, maybe you have like 2 or 3 like one-off like use cases, it could technically be your catalyst. But like, trying to, do you usually recommend to clients like, hey, hold off on this like as long as you possibly can? Or, and so that would probably require some sort of like, manage or kind of like Band-Aid solution that gets you from, that point where you do have a couple use cases that maybe make sense, and then get you across the line. Or do you just say, well, there's just, I mean, if there's like just enough, I guess it depends, like, will it be more use cases coming in the future or not? And so what is your general advice around like, trying to figure out at what point, when we do have a couple use cases, is this a catalyst, or is this like just a couple use cases that came out of the woodwork and we can actually get by for maybe another year or 2 years without having to go straight to CDC?
I would say for most stuff in the data world, I tend to tell people wait. Like at least my approach on most things data related are assume everything's going to change in 3 months. Assume your company's strategy, every KPI, every analytics dashboard, every workflow is going to get blown up and you're going to start over 3 months from now. Okay. Just because most companies fundamentally change their strategy, their KPIs, which typically inform the dashboards you build, there's only some things that will pretty consistently remain quarter over quarter. Things like products. Like if you were powering a product for customers and that product, like the minute you sign a customer on anything beyond an alpha product, it's not going to go away, because like unless your team's very, very good at deprecating stuff, which very, very few companies are good at deprecating things, once you power a thing for a customer, it's not going away. So like that's a very, very good catalyst. Same thing with any sort of reporting. Like again, once you start reporting stuff to investors, it's a slippery slope of you need to make sure that stuff's production grade. I would say anything internally when it comes to analytics, my take personally is like assume everything's going to get blown up unless you see a clear path 6 months to a year in the future where you have to have this. The minute you see that, the minute you know that there's a couple, like even if it's just one workflow that is going to be around for 12 months, think through a solution that scales to that point. But I think having 2 or 10 different use cases today that are all ad hoc reports, like that are not, okay, we have someone signed up for this for 12 months, is typically what I recommend. But it's not too difficult, especially as your data team scales and your company scales, to end up with that 1 to 2 production use cases. And then at that point you should be like, okay, cool, these are going to live longer than a quarter. Like, let's actually plan for this, because your warehouse costs can blow up. Your other costs, your people costs are going to be more expensive than your CDC costs every day. Like whatever your data team is always going to be your most expensive cost, and paying for vendors, paying for solutions, if it'll save you headcount, like something that you should always constantly be thinking about.
Yeah, good point.
Okay, let me put it this way, or slightly different question. Playing the devil's advocate, okay? I think I can do all the auditing and all the production usage, as well as all the analytics usage that I need from just sending out specific logs from my prod database, from my prod application. I do not need to replicate my whole database. What do you say?
You're speaking about in a CDC, like, is CDC right for me type conversation?
Yeah.
I mean, there's a couple things there's a couple pitfalls I've seen when trying to take that approach. And I have seen that before, where customers are kind of evaluating the need for getting data from Postgres to Snow. I'll just use that as an example. And can I handle that better upstream, right? As I'm writing data into Postgres, can I also write it into Snowflake or something like that? Let's not rely on the database for replicating those changes. Let's rely on some other upstream process. I mean, there's a lot of scariness to that approach. There's lots of people in an application architecture that have access to the data to manipulate things that aren't necessarily doing so through the application, right? So in many use cases, you're going to need the data itself to be replicated in its where it's stored, not just in the application itself. There's also an element, and I'm going to grit my teeth as I say this, but like when you start to set up some of these analytics pipelines, a lot of them start with like one table. I've got this one table in some system that I need to get into my data lake or warehouse because I've got some analytical use case that needs data from that table. But then a lot of them eventually evolve quickly into, I now need this other table, and now I need this third table, and now I need tables from this other system. And now I don't just need a batch update of this table, I need an audit trail of data within this table. And so while I'm never in favor of this goes back to my over-engineering comment, I guess, from an hour ago, where I said, don't do this, but now I'm almost saying, think about the need to potentially consider future state use cases where, right now I'm getting asked for one table, but what is that request going to turn into? And I should build this on an architecture that can scale to support additional use cases when they come up, versus needing to go back to ground zero and rebuilding the use case from the beginning, because now I need 1,000 tables, not just one. Saying, I'm being asked for these 5 tables. I've got 500 tables. I'm just going to replicate all of them because I don't know what I'm going to need in the future. And I want to build something that scales as high as it needs to now, because the requirements are going to change. And I don't want to have to re-architect everything in a year when the requirements have changed. So there's a balancing act. This isn't necessarily just a data engineering concern, but it's why I am kind of a fan of CDC, why I am a fan of CDC for a lot of data ingestion technologies, because it is scalable. I mean, you have to do things right to scale it. It's not just scalable, natively with a single button, but it can scale, and it scales very well when done right.
I think the dimension that we've been sort of glossing over is how much of a lift is it for you to put a CDC pipeline in place and to do this. So yeah, if you have a great vendor who knows what they're talking about and can inform you of the choices before you go and do this, like that's probably a great solution, right? Especially if you are okay with the price of moving those 300 tables. But I think there are also situations where someone says, oh, I'm pretty sure I'm going to want this every 10 seconds, and like over engineers and does crazy things. And so the cost profile of a CDC solution can be radically different across approaches. So yeah, if you're doing it right and you have a way to like get it done, and it is like easy to set up and onboard new tables, easy to know what your guarantees are and maintain the mirrors, things like that, then yeah, CDC can be an excellent solution.
It does kind of remind me of, when I stood up the data team at LiveRamp, or the BI team at LiveRamp, I put in place a centralized data team, but there were already data teams in place in marketing, in product, in finance, etc. And as I said, the most expensive cost in most scenarios is people. And we started meeting once a week, and it was like, hey, what are you focused on? What are you focused on? And back to the point of, you start with just one table and you ask for more. In a 1,000-person company, when you have to ask, where security and privacy are paramount to the business, every time you ask for another table, it's another 3-month-long process. So like the other consideration here about, yes, wait as long as you can to get started. But if you're inside of a big company where you want a decoupled engineering team and a data team, there's a lot more than just, oh, let's replicate all of our data into Snowflake or all of our data into BigQuery that comes with this. It's like, okay, if we replicate all the data into our data warehouse, how do we permission that data? How do we actually put in place the security controls we need? Doing that table by table, you won't spend time doing anything else for the next 2 years. So there are benefits when you are going through bigger digital transformation initiatives or standing up data teams at bigger companies where they haven't had the infrastructure in place, where the cost of going table by table on every aspect of this, there's a benefit of just being like, we're going to solve this problem once and for all. Let's put all the data there. Let's permission it. Let's make sure we have the right governance in place so that even if we don't need 30% of the tables ever, at least we don't have to keep asking every single time we need the next table.
And that gets right back to like what Santona was saying about like the cultural, issues that you run into, right? And so you're actually just, increasing your agility, and then, also saving, most expensive headcount really, or most expensive cost is headcount. And that's what you're basically having your headcount focus on is interacting with each other, and humans are actually like the slowest of the entire pipeline that we're talking here. Like that's the slowest element in terms of getting things updated, changed, and moved forward. So if you can actually build process using one of these things on top of building, the actual technical infrastructure that's required for this, then that's actually going to be not only making your business run faster, but then it's also going to be really focusing on saving the time and focus of the people you're paying for. You don't have to hire more people to fill in the things that act like the day-to-day work that actually needs to get done, rather than meetings. And everybody loves meetings.
I would also add that we don't have them on the show today, unfortunately, but a certain Trino company may argue that query federation is probably the best approach to kind of start small. Right? Yeah. Why replicate some tables and not other tables? Just do query federation, right? Query the data directly where it lives. Yeah. And only when you have high volume of, queries that you got to run and it makes sense to replicate to the lake or to your warehouse, that's when you do it. Like I have different perspectives on this. I think query federation can get really, really difficult really fast. And it can have, some security impacts, performance impacts. But regardless, I just kind of wanted to put it out there and see if anybody had any thoughts on, query federation as an on-ramp to CDC.
I actually agree that it's a very simple way. I would not federate queries to the production transactional database, but if you can get by with a read replica, then that can be a really nice system. It again depends on how easy it is to manage and set up that read replica and the cost of that, versus how easy it is to manage and set up the CDC pipelines. If you're building it yourself, use a read replica until you outgrow it. If you are working with a company like Tabular or Upsolver to manage your data in S3 or Snowflake, then there's much less cost to doing it that way, right? You can get those CDC pipelines up and running very quickly and cheaply. So I think that it really depends on what's already in your infrastructure and how you want to spend your people's time.
Yeah. And I'll argue having both actually is the best of all those things, right? Because then at that point you're able to solve both the smaller cases with one technology, and then slowly adapt and grow those into the larger kind of like consistent use case, like constantly doing this kind of large transactional process over and over and over again at scale. So.
All right, I want to throw out one last question around the table as we wrap up. Before that, I refrained from making quips throughout the show, but earlier when someone was speaking, I was thinking like the summary was your real-time pipeline is as fast as your slowest batch, and then by the end of this conversation, it actually evolved to your real-time pipeline is as slow as your humans. Right. So there's that. Yeah. Okay. For the question, how do folks think about data quality? I mean, and not in very general terms, but very specifically, as you're doing CDC, we're thinking about the consistencies, and we have to make sure that there's like soft locking around transactions and stuff. Which, by the way, Ryan's blog is a really good source to like learn how to think about that. But beyond that, is there room for in-flight quality enforcement, or should my replica be exact? Especially if I have a use case in mind, let's say an analytics use case, and I want, I'm a data analytics team, and what I'm really asking for is a CDC solution that gets my prod data into analytics. Should it be exact, or is there room for some quality stuff?
So when would you want to reject a change and have that mean that your mirror is out of date with your production data.
Yeah, let's say I don't want to reject any of my change events. However, well, okay, so we can come at it from the security angle, right? Should I be looking at masking values as the data is going through? Should I be looking at or alerting is another one, right? So we have you know, health monitoring and stuff often are like standard now in applications, but data-based alerting, right? This value is way out of whack from what it should be. Like, should I be looking at the data as it's coming in a CDC pipeline?
I mean, you definitely can. The masking use case makes sense for inline transformation. It also makes sense to like maybe trigger data quality, you know, alerts or something like that off of these events. I just like the very narrow question of should I do anything about it? You can notify people, but I don't think that anyone wants the production nightmare of wondering whether this table is actually in sync with the upstream database.
One question for you, I guess, one scenario where things could become, to your point, Ryan, of like, why wouldn't someone just want all the data? Is like, this might be wrong, but to the best of my knowledge, trying to load very large data sets into Redshift specifically, like you have to truncate the data that goes in certain scenarios. It's like that's a scenario where what is the right answer? Like there probably is, like it might just be don't use Redshift. But it's like in those types of scenarios where like every potential destination can have its own weird limitations. And I guess potentially part of the question is like, what do you do in the, like, you can't like if you're pushing to APIs, it's like you have to dead letter queue stuff that you can't actually deliver. Files and databases and data warehouses have more flexibility, but they all have their own weird edge cases.
So my recommendation there is to go to a format that is portable and accessible across as many of those systems as possible. I think that that's becoming a best practice in general as we transition to analytic storage that is separate from the compute vendors, which I actually just wrote another blog post on. So go check that out. It's about independent storage and why it's important. But here I would say, like, don't let yourself be handcuffed by the representation of Redshift specifically, right? Make it available in an open format to Redshift as well as others, right? So you can land that data in Iceberg and read it from Redshift. And if that works in Redshift, you're okay with that truncation on Redshift, go for it. That said, Iceberg itself has some limitations in this. Like we've already hit on two. Number one, we don't support the full range of like type promotions because we like to make sure that hashing and things like that are consistent across type promotions. Anyway, so there are some limitations like, hey, you can't cast or you can't change a database column from long to string, for example. Doesn't bite you very often, but when it does, that sucks. And then another is the default values. You know, if you set a default value in your upstream database, do those default values actually, you know, do you have a way of enforcing the same default values with the same SQL behavior and with all those guarantees? I can say that as a format, we're working on both of those, but there are still edge cases that are going to bite you even with the common formats.
Why don't we give Jason the last word on this, because he's been pushing for some observability and quality features into Absolver, which I fully support. But yeah, and then we have to wrap up.
My commentary on that last point is, you know, data quality is something you should always, or as often as you can, address as early in the data generation process as possible. I don't think that's a earth-shattering statement. So if I'm ingesting data, let's say from Postgres into Snowflake or a data lake table, I want that data in Postgres to be of high quality as it possibly can be. And in most cases, if I can trust that, then I'm going to do a direct data ingestion from Postgres to Snowflake. And there may be some things I have to change in the data if I'm masking PII or redacting some columns that can't be written for security reasons. But in most cases, I want that data to be of high quality, and I'm going to trust that it's of high quality in its source. I've run into problems with several customers, though, where they, one, can't make that guarantee. And if they do find bad data being ingested into their data warehouse, they can't fix it in the source. And so the only real, maybe it's a vendor app with off-the-shelf software, and they can't go to that team and say, hey, you're writing malformed strings into this field, or you're writing integers when you should be writing decimal precision numbers. And so if you can handle improving that data quality on ingestion through some form of ETL or, some in-flight transformation process, then I think that's a better place to do it than to wait till it gets into the target and then have to fix it after the fact. Right. So I'm a big believer in it. My preference would always be improve data quality at the source. If it can't be improved at the source, then improve it through ETL. And I want my data warehouse to have the highest quality data it can have, and I'd rather transform it more simply, upstream than downstream.
Yeah, completely agree. We probably should wrap up, Shantanu.
Yeah, great point. And thank you so much. Ren's already hopped off, but thank you, Ryan. Thank you, Brian, Ethan, for being here, and of course, Jason and Roy. Thank you as well.
Thanks for having us.
Appreciate it. It's been a long one, but this has been fun.
Totally. Had a blast.
All right, guys. Take care.
Bye.